So we're going to work on 283.
Actually, I have like a 1 second question after this.
Okay.
For this one, isn't this exactly the same thing as like 320? Shouldn't it be?
But it's, that 0 is after.
Even though it exists in a different state, it's like the existing two states.
Right, because if you didn't put the 0 there, then it wouldn't be significant. So if it was like 320, it would be 3.2 times 10 to the whatever.
Oh, because the decimal is defined.
Right.
Okay, so let's take a look at 283. All right, so a runner wants to run 10 kilometers. She knows that her running pace is 7.5 miles per hour. How many minutes must she run? Okay, so then they tell you use 7.5 miles per hour as a conversion factor between distance and time. Okay, so on 283, what did you use as your starting quantity?
Miles.
Okay,
I feel like I was solving for the wrong thing. I just think my whole thing was wrong.
okay, so when you look at this problem, so we're looking at 83. When you look at this problem, there are two givens. So 10 kilometers and then 7.5 miles per hour. And so they're telling you to use 7.5 miles per hour as a conversion factor. All right, so our given 10 kilometers, and then our conversion factor 7.5 miles per hour. We're asked to find the amount of time in minutes. Okay. So your road map or your conversion map is going to look like so. You start off in kilometers. And we want to get to minutes. Okay? So you start off in kilometers, we're trying to get to minutes. We have a conversion factor that goes miles to hours. So we could conceivably have hours to minutes, right? And then if you go one back from that, this conversion factor, miles to hours, so this converts between hours and miles. So then you have miles here. Is this a reasonable road map? Can you do kilometers to miles, miles to hours, hours to minutes? No?
No.
Why do you say no?
How you gonna get a mile to an hour? That makes no sense.
Oh, but you have this conversion factor right here.
So for every 7.5 miles that we have, we're gonna have 1 hour.
Exactly. Yes.
I was way wrong.
That's okay. It happens, especially with these dual unit, you've got all these words and it gets confusing. So, no.
It's like playing the wrong game.
Yeah, no, that's okay. That's okay. 10 kilometers over 1. What's your conversion factor for kilometers to miles?
I think I have one.
It's 1 kilometer is 0.62 miles.
62. And is your book, does it say 0.6214 in your book?
For the answer?
No, for the conversion factor.
There's conversion factors in the book? I just looked at the sheet it gave us, you said it was 1.61 kilometers.
1.61 kilometers. Let me check out this. Yeah. All right, so 1 mile, 1.61 kilometers. Okay, so we've gotten through this first conversion. So now we're going to use this crazy conversion factor that goes miles to hours. So we want miles to cancel out. Are we going to flip it or use it the way it's written?
You're gonna flip it.
Flip it. Good. Very good. And now, what do we do? So one more conversion, hours to minutes.
To go, convert the hours to minutes.
Yes.
So the hours need to be on the bottom and minutes need to be on top so that they cancel.
Good.
Can you just flip the miles and hours, or does that require some kind of mathematical change?
Oh, can we just flip it like I just
You
did?
can just flip it upside down.
There's no mathematical change as long as you recognize that 7.5 and miles are stuck together. They do not, sometimes I'll say they're married and they don't get a divorce. They can't get a divorce. And so 1 and hour are stuck together too. When you start changing around the units and the numbers, then it becomes problematic. Okay, so what did you get when you entered this? I have a calculator here too. Anybody else need a calculator?
Can I borrow?
Yes. So we have 3 significant figures, right?
Yes. So what'd you get?
49.7.
49.7 minutes. Very good.
Wow, that sounds easier than what I was trying to do.
Sometimes it can get confusing, and if you ever, did you try your solution map?
You mean like the road mapping?
Yeah.
Yeah, I did that. I went miles to feet to inches to meters to kilometers, which I don't even understand why I would do that anymore.
Yeah, you're kind of going.
Yeah, we're going in the wrong way.
A lot of times it's like a puzzle, and you just need to kind of rearrange things.
I'm
Yes,
not
there is.
using that answer.
Okay.
Your calculator.
I got 0.6.
I don't know what your answer is. Multiplying by 7.5, you should divide by 7.5. Okay. Let me write out what you should enter in your calculator and then see if you get. Okay, so the calculator, you should have 10.0 divided by 1.61 divided by 7.5 times 60. Does that make sense for you? So you take 10, you divide it by 1.61, you divide it by 7.5, and you multiply it by 60.
I just go across.
Yeah, I do too, so it's like weird.
Okay, so you go across like
10.
10 times 1 times 1 times 60.
Mm-hmm.
Yeah, and
Okay.
then I divide that by 1.6, and then or multiply it, but I guess I should divide it.
Okay, so you can do it 2 ways. So you can have 10 times 60, which gives you 600.
Well, because I went all the way across and I got 600, and then I multiplied all the way across on the bottom and I got 12.075. Then I divided the 2 and then rounded 1 up, so I got 49.7.
Okay, so when you do this, you just need to make sure you carry everything through. Okay? Let me see what I got. So 600 divided by second answer. And carrying your answer through is a good idea. And that's what I get.
Okay. Is that what you got, Mauricia?
I see why you guys got it. So.
Okay. I know, sometimes it's like the calculator part can be the hardest part. You got it?
No.
Let's see. Okay. Are you gonna have it right now? So that's this. Is that even? 600 divided by that. So your units would have come out to be 1 over minutes, so inverse minutes. I know. Like, how do I time an inverse minute? Yeah. Okay.
Also, check out number 85.
85. Okay, wait, Becca had one.
It's on 77.
77.
And it's a table. What is GN and TN?
Oh, okay. So this table on 77.
Yeah.
Don't worry about GM and TM.
Okay, I didn't do it because I wasn't sure.
Good. Good. You're right.
And that's it. I don't have another question.
Okay.
Is that gigam?
Yeah, I was like, what
It's
is
Giga and
tera.
tera? Giga and
Yeah.
tera?
Oh, I thought it was like a metric ton on the last one. I just did what, I didn't want to try.
You're just.
Yeah, I did it, but I didn't do the last 2 columns.
So what were you saying, Lizzie?
Did you say 83 or 85?
Oh, I tried another one.
We just did the 80 to be on them.
So 85? Okay, so 80. All right, the recipe calls for 5 quarts of milk. What is this quantity in cubic centimeters? So you're given 5 quarts. You're asked to find the cubic centimeters. Yeah. Okay. So did anybody work this problem?
I did when I Googled that 30 cubic centimeters is 1 ounce.
Okay, 30 cubic centimeters. Let's see. So what was the conversion factor you used, an ounce?
1 ounce is 30 cubic centimeters. Is that right?
Yeah, you can use that one.
Okay.
Or in your textbook at the back, there are conversion factors for volume. So you see the quart, and then you also see cubic centimeters. Okay, so 1,000, so our conversion factor, 1,000 cubic centimeters equals 1.057 quarts. What's our starting quantity in this problem?
5 quarts.
5 quarts. 5.0 quarts, good. All right, now how are we going to use our conversion factor to get quarts to cancel out?
The quarts would be on the bottom. And since you have the direct one, instead of going from quarts to pints, like I would have, you can go directly to the cubic.
Exactly. Excellent. So that cancels out. And so 5 divided by 1.057 times 1,000. Four 7 3 0 3 6 8 9 6 9 cubic centimeters.
So you took 5 or divided by the 1.057 times 1,000.
Mm-hmm.
And when I was writing it out with you, the way you have it, I have my 1,000 3 times because it's cubic.
Oh, no.
No?
This one, this conversion factor, it's not just, if it was just to straight centimeters, then you would have to cube it, like you did. But see, it's already cubic centimeters. And if you think volume is length times width times height, so that's centimeters times centimeters times centimeters. Yeah. And, like in the healthcare field, you hear like cc's, that's cubic centimeters. That's just, instead of saying cubic centimeters, they'll say cc's. Okay, now how many significant figures should I have in my answer?
2.
2. All right, how do I make it 2 sig figs?
4,700.
4,700. Excellent. Good. All right, other questions? I know.
On 79,
79.
I understood them, but the way I did it, I wrote them all out completely and just moved the decimal point. Is there a simpler way to do that?
No, that's a great way to do it.
Could we have converted it?
You converted it, yeah. So on 79, okay. So you're asked to take 2.255 times 10 to the 10th grams and convert it to each one. So what your work would look like, 2.2, if you do the conversion factor method. And I gotta put my units on this. Okay, so grams. So you'd have grams to kilograms. So, and 1 kilogram, there are 1,000 grams. Then you would do same thing. I'm just going to put this. So grams to megagrams. 1 megagram, 1 million grams. Milligrams. Grams to milligrams. 1 gram, 1,000 milligrams. And then lastly, metric ton. So that would be 2 steps. So you have grams to kilograms, and then kilograms to metric ton. So it would be, they give you the conversion factor. 1 metric ton is 1,000 kilograms.
Is that the same thing as a megagram?
Yes. Because you're moving at 6. Good questions. Good questions. Other questions? Okay. Good deal. All right, well, let's go to our notes if you don't have no more questions. All right, when we stopped the last class, we were working the density problems. Remember, density is mass per unit volume. And did any of you have any trouble with working density, or?
I kind of have a problem like distinguishing which one is which, like if it's mass.
Oh, I see what you're saying. Okay, so I think that's a common problem. So okay, so we have density, we have mass, we have volume. The units are going to be what tells you which is which. See what I'm saying? So that's going to be an identifier. Okay, so your units. Units for density can be either grams per milliliter or grams per cubic centimeter. Mass can have units of grams or kilograms, or any variant of grams.
I don't understand where you wrote for density.
I was just writing the units. Grams per milliliter or grams per cubic centimeter.
So that's under the unit?
Yes, that's under the units. So we're just going over what units each property can have, density, mass, volume, so that you can identify it easier in the problems. I'm just going through and defining, reviewing.
Is it kind of like an identifier? If I see grams per milliliter, I know density. If I see
Right.
grams or variation of grams, kilograms,
Then it's
megagrams, it's mass.
yes.
Okay.
So like when you're working this problem, like milk has a density of, I mean it says density of, but sometimes you're just so freaked out. You say, oh wait, grams per milliliter. This number is density.
So it's not units over grams over milliliters?
No. This is
Okay,
just
that's what I
the
was confused.
just a table, yeah. And then like this, if you look at this unit, a unit of milligram would be
Oh, so it's mass because
It is
it's
mass.
a variation of a
Mhm.
gram.
right.
Okay.
So I'll put or any G.
I think an easy way to think about it is that density in your units are a fraction.
Yeah.
And always will be.
That's a good way to look at it.
This isn't a formula, right?
No. This is just a review table, yeah.
If mass can be anything, why do we have to convert megagrams and milligrams?
Oh, milligrams, it can be any gram. You know, so it can have any prefix multiplier. It could be decigrams, milligrams, centigrams.
Okay.
Lizzie.
So if we see these units in a problem, that means that we're going to be solving for
Something else.
right. Okay, so like for instance, question number 3 says milk has a density of 1.03 grams/milliliters.
Mm-hmm.
That means we're looking for the density.
That means you're given the density.
Okay.
So it helps by just reviewing what units, we're trying to make it easier to figure out what you're given and what you're trying to find.
Okay, and then that goes back to the triangle thing. So then, right, that's the one that we cover up. So for instance, to figure out this one, we would divide mass by volume.
Okay, so volume, typical units that you'll see with volume. You can see milliliters or liters or cubic centimeters. So those are typical units that you'll see. So this will make it easier for you to identify what's given. Okay. Any other questions about density? Got it straight now? Yes, Marcia.
I got this density of it. I have a statement of this. If you see me texting, it's not just, random texting. I'm texting my mom because her and my dad went out of town. I had to watch my little sister. So.
Thank you for letting me know.
Okay.
No, I understand that. Yes, Lizzie.
I was wondering if you could give me an example
Okay, so an example of density, like a problem, or just
Like what it is, like what it means. I don't even know what density means.
It's a way of expressing two physical quantities. So a mass per unit volume. So you know, like if you have ever had somebody say, "Oh, they're really dense."
It's like it's hard to get it through their head.
Right. Like a brick compared to a feather.
Oh, so like there's more inside of it?
Oh, like a foam block compared to a brick. Because the foam block has less density to compact it. The like particles inside of it aren't as close.
Okay, so density has to do with the closeness of the mass?
Imagine it like a pillowcase. Like you have two pillowcases, and the more dense pillowcase is one you stuff in.
Yeah, so you put more mass and the same volume.
Okay, so does that have to do with like the number of atoms per?
Okay, so density is this one.
Yeah. Thank you.
Very good. I know sometimes it's hard to wrap your brain around it all. Good. Okay, so now we're going to kind of diverge in Unit 1 and get away from so much conversion factor stuff. So if you're still a little iffy on conversion factors, keep practicing. We do have exam 1 the next class. So definitely study, go over your homework again and again. Now we're going to get into a lot of definitions. So these are things that you can see like multiple choice questions or true-false questions. So more factual stuff, not so much problem solving. There will be a problem solving portion on the exam. So
Problem solving
Like conversions, right?
like what?
Conversions, right?
Like conversions, like your homework problems. I could just take a homework problem and put it on the exam and say, you know, do 283. I mean, I would give you everything, but yeah. Yes. Lizzie.
I was wondering if there will be a study guide online?
Yes.
Okay.
Yes.
And we still have a place with the test coming up, just over.
On days where we have exams, we will not have a quiz. Yeah. So just one, not both.
We are included.
Okay, so we're going to talk about matter. We're going to distinguish between solids, liquids, and gases. So this is kind of a little lighter material, not as dense. Yeah. Okay, so matter is anything that occupies space and has mass.
Massive, like weight, right?
Right.
Okay.
Yes, like grams. Like you use, when you go into a chemistry lab, you'll see balances. That's what you measure mass with.
So mass is anything that, like, I'm gonna let you go and then hopefully it'll be
Okay. Okay. So atoms are the building blocks of matter. So anything that you see has matter. You're made up of atoms. This desk, floor, the door.
That's how I feel right now.
Not my children. It's very happy running around, but
Did you say everything is made of atoms?
yes.
Okay.
Mm-hmm.
So there's no place where there's no atoms in space, do you think? Or do we not know?
That's a good question.
This raises a lot of questions for me about the universe.
Okay. I will look that up for you, and then
They debate it. It depends on
Yeah.
if you believe in the God spark or which one you believe how the universe is
Right.
formed. Based on that belief, it what answers that question.
That's a good point.
but you know what? That's not going to be on the test.
So matter is made up of atoms and mass is made up of atoms.
Yes.
And the difference between matter and mass is what?
So mass is something that you can measure. Yes, it's a quantity that can be defined. You can measure it using imbalance.
Okay, molecules. Water is a molecule. So 2 or more atoms
Is the compound, one
bonded
element?
together.
So a molecule can have many elements, but a compound can only have 2. Is that right?
Oh, you can have compounds that have more than one. So they're just bonded together. We're actually going to talk about them a little bit later.
Okay.
Are these related though?
Yes, they are. Molecules and compounds. So you could say compounds as well.
With the definition that we're using. Okay, so we have 3 states of matter that we're going to talk about. There are other states of matter that we don't get into in this class. It may be in your other chemistry classes you get into more of the gel and the sol. So, yes.
So I have a question. I just wanted to verify this. So a molecule is like H2O because there's 2 or more different types, but is O2 considered?
O2 is actually an element.
So it's just elements, not molecules.
Right.
It has to be 2 or more different elements.
What's that?
Element is one?
An element is one, unless you're talking about the diatomic elements.
Oh, well, right, I know.
Like elements are how we categorize atoms, right? So like
Right.
basically like we have like hydrogen atoms.
So when you cut down anything to its small size, like you have a piece of aluminum foil, and you keep cutting it, and you reach the smallest size, that's the atom. But it still can be identified by the fact that it's aluminum. Okay, so the atom distinguishes because of the number of protons. And we'll get into this, these are great questions. But yes, elements make up molecules and compounds. So by and large, it's one element, like in its pure form. There are a class of elements called diatomic elements that when you find them in nature, they always exist in 2s. Oxygen is one of them. So if you've ever had car troubles, your O2 sensor is faulty, that's your oxygen sensor. And it's so there are like hydrogen, oxygen, fluorine, HOF, bromine, iodine, nitrogen, chlorine. Those are all the diatomic elements. Hofrinkel is how we
And
refer.
O2 is a free radical. Is that right? You don't need to.
No, it can generate free radicals.
Somebody
But-
brought that up in my class. So I was like,
No, it can be, it can generate, but you have to have something to initiate that free radical process,
okay.
which, good. Okay, so we're going to talk about solids, liquids, and gases. There are 2 types of solids that I want to distinguish. Crystalline, so you have atoms and molecules arranged in geometric patterns with order.
So that'll be some.
But it's, order. Have you ever shown somebody the trick where you have a drink and it's sticking to your napkin?
You put the salt on
You
the
put the salt. Why does that work?
The salt absorbs and makes a barrier between the two.
Yeah, and if you look at the structure of salt, like if you find like one little granule, it's like a perfect cube. So it creates like a little table for that drink to sit on so that it doesn't stick to the napkin. And that has to do, it's a crystalline solid.
So salt is a crystal.
But it can be.
Okay.
And I'm going to go ahead and clarify. I'll put compounds here too. So crystalline solids have order. Amorphous solids do not have order. So crystalline solid, it's very efficient. They're packed in there very neatly, and NaCl is a perfect cube. So amorphous solids, atoms, molecules, compounds that do not have order.
What's an example of amorphous? Because most like metals or crystalline, stuff like that, they have really rigid defined structures. But what's an example of one without order?
My brain's trying to figure this out right now.
What's that?
You said an example. I said my brain's trying to figure
Yeah,
this out.
you're just an amorphous. I like that.
Would be like water, because they don't really have a small, they kind of.
They
Water is
do.
a liquid.
But when it's frozen,
Yeah, frozen.
But it still has order.
Yeah.
So when you say that they have order, does that mean that the molecules don't move around?
Or they only live in a specific pattern.
they always move, yeah.
That just means like the kind of thing more like as a whole kind of? That's like how these liquid substances are called.
Okay,
Yeah.
here you go. Amorphous solids include glass, rubber, and plastic.
I was told at one point that glass is a liquid, it's just a very dense liquid. Is that what we're touching on right now?
Okay, let me just write examples for crystalline. So you have salt and diamond.
I think I read the same thing. So you talking about like how glass is actually always a liquid, but it's just so dense. And then
Right, and like over time this
it'll like
is,
shrink down.
Mhm.
Yeah.
like if you go to really old houses, it's what glass is so thin.
And the leaded glass too, yeah.
Is there a difference between table salt and other kinds of salt?
There are, because of the minerals that are in the salt, like, you know, you can get, it seems like it's becoming more and more popular now to get this fancier
Yeah,
salt.
sea salt.
Yes, yes.
So would that apply to this? Would a table salt be different from a sea salt?
You might find different crystalline, or, you know,
But
like
it's
it's,
still crystalline.
right. Good. Good questions. Okay, so then we have, solid, liquid, and gas. We're going to go over the different properties of solids, liquids, and gases. And regardless of which chemistry class you go to, you will see this again. So do solids have shape?
Yes.
Yes, so they have definite shape. Do liquids have shape? No. What happens if you pour out, now my water is it's in the shape of the container, right? So it's,
I guess I was
yeah, so if I pour it on the table, it will go everywhere. Right. So it's indefinite for what were you saying, Angela?
I was imagining like when you have like one drop of water part kind of stays with a little ball.
Mm-hmm.
But I guess if you're taking it in bigger quantities, that is true.
Yeah. All right, what about a gas? Does it have shape? No, it's indefinite.
So, can you just write no? I don't even know.
Yeah, you can write, yeah.
So that's just your word then, indefinite, which means no, right?
Right.
Okay.
Yeah.
That's just right.
All right, does a solid have volume?
Yes.
Yes.
All right, so I'm gonna, you know what, for you, Lizzie, I'm gonna say yes. Okay, does a liquid have volume?
Yeah.
Yes.
Yes. All right, what about a gas?
Yes.
Yes. It's indefinite. It's the volume of the container.
Okay, and that's the same when you say indefinite on shape, is that it takes up the shape of whatever container it's in.
Shape
Okay, so the shape is indefinite.
container.
And volume is kind of like the measurement of the space it takes up.
Yes.
Okay.
You know, if you think about a 2 liter of pop, that's volume. So
How can volume be indefinite for gas if we can measure volumes of gas? Because we can't.
you can. It just has to be contained. You know, so like you have the gas cylinders, they definitely have gas in the liquor in that container.
So could we measure the amount of gas in the room?
You could.
So how big is the container for us to be able to measure?
You could measure lengths. So you would just do the length and width and height, and then you'd have to look at this temperature and the pressure.
But like outside,
It
because we can do
varies.
that.
It varies, yeah.
So just the difference is that the volume can change, right? Because if I have like a bottle of water and I dump it out, its shape will change, but the volume remains consistent. But if I like release a canister of gas in the air, its volume will change as it expands.
Okay, so atomic motion, molecular motion. So, yes, kinetic energy. So with a solid, you still have movement, but it's at about a fixed point. So you have vibration about a fixed point. With a liquid, the molecules or atoms are free to move about relative to one another. So there's motion. And we'll talk about the spacing in just a minute, and this will make some more sense. The gas, same thing, are free to move about relative to each other. Okay, so what do you think about the spacing in a solid, liquid, and a gas? Which one would be closest together? Which one would be farthest apart?
The solid would be the closest gas.
Yes. Yes, exactly. So solid is close together. A liquid is close together, not as close as a solid. So I'll put closest together for solid, closer together for liquid. What do you think about a gas?
I think it's like bouncing over.
Far, they're very far apart. All right, so what do you think about compressibility for a solid? Can it be compressed? No. So can't be compressed. So
Not at all. Like minimum or rigid compression?
I think it would depend
On the solid?
But I think you're also destroying the solid at some point, you know, so it's, yeah.
So it'd be no compression because in order to compress it would destroy what you originated with.
Right.
When you compress it, it adds density, right? It's making it more dense in a smaller, vicinity.
Yes, and it depends on how you have it set up. Because if you have pressing this way, then it might spread out that way, you know, so like the density of any given point would stay the same.
I was just remembering these like compressor things, but they were compressing a lot of it. It's like a cylinder,
Uh-huh.
and it has this thing that puts just like ridiculous amounts of pressure in a really long time, and it has they take like the bedrock in certain areas and try to see how long or how much like a building could,
Mm-hmm.
you know, weigh and be on that space.
Right.
Did you, explain how, why solids are not compressible?
So their spacing is as close together as they're going to get.
So is that trying to smash it off without smashing it?
Right.
Okay.
So why wouldn't something like a foam tube or a pillow that you can, I mean, you're compressing the cushions together, aren't you? But that's still solid, isn't it?
You're compressing the air within it, because
Oh,
like the particles themselves, you can't crush a particle. But like if there's like two particles next to each other, they're both solid, you can push them together.
okay.
When you think about a pillow with feathers.
Yeah.
What'd you say?
So I think he wants to take it out.
I know. Okay, so a liquid is incompressible. All right, but a gas is compressible.
That's how they get aerosols. Right?
All right.
Do you have any special definitions for